All right, special solutions. When I say special solutions, what I mean is we solve something and kind of something weird happens. Does every equation have a solution? Can you just solve everything all the time, no matter what? No. Have you guys ever encountered something that has no solution? Probably at some point. So that's what we're going to be looking at today. When something ends up with no solution, or sometimes even infinitely many solutions. That means any number that you plug in could work. So equations don't always have one solution. Everything we've done so far does, but it just doesn't always happen. An equation that is true for no value has infinitely many solutions. So, oh wait, no, sorry. I wrote that wrong. Go back. Lying to you. An equation that is true for every value, or for all values, however you want to think about that. Has infinitely many solutions. So equation that is true for every value has infinitely many solutions. That means any number you plug in could work. Now, what does that look like? Well, when you get to the end of your problem, you'll know if it's infinitely many solutions because it's going to look a certain way. You're actually not going to have a variable anymore. Your variable will cancel out. And what ends up happening is you just end up with a true statement. Maybe something like 0 equals 0. Does 0 equal 0? Yeah. Or maybe you end up with something like 5 equals 5. Does 5 equal 5? Yeah, all the time, right? You'll end up with something equals itself. That tells you, hey, this works for anything. Sometimes, though, it doesn't quite work out that way. An equation that is not true for any value has no solution. What that's going to look like is your variables are still going to cancel out, but you're going to end up with a false statement, basically, something that's not true, like 0 equals 5. Does 0 equal 5? No. No, that never works, right? You end up with something that's not true. Or maybe something like, I don't know, normally you end up with a 0 on one side, like 0 equals -2. Does 0 equal -2? No. So if your variables cancel out and you end up with a true statement, it's infinitely many solutions. If everything cancels out and you end up with a false statement, it's no solution. Okay, so, and we're just going to practice what that looks like. So our equations are going to look very similar to what they did yesterday. We're going to maybe need to distribute, do our 2-column method, but sometimes something might cancel out and we're going to see. Okay, so solve each equation, determine whether the equation has one solution, no solution, or infinitely many solutions. If it has one solution, you're going to get an actual answer, right? No solutions, you're going to get a false statement. Infinitely many solutions, you're going to get a true statement. So let's look at number 1. What is the first thing we need to do in a problem like number 1? Distribute. We have parentheses, you need to distribute. So we're going to distribute our 3. What's 3 times 5x? 15x, very good. Then 3 times 2 is? 6, good. Equals, and drop down your 15x. Now you guys might actually already even notice something about this equation. Look at the left and the right-hand sides. Is there something you guys notice? 15x is on both sides, right? So what's going to happen is when we rearrange this, if you have things that match, but their signs are opposite, won't they cancel? Like, isn't 5 minus 5 0? So what's going to end up happening here is something's going to cancel, but let's see what that looks like. So I'm going to put my bar for my two columns, and let's decide what's going to stay, what's going to go. Is 15x going to stay or go? Stay. What about the 6? It's going to go and become negative. Good. And what about the other 15x? Very good. It's going to go to the other side, and it is going to become a negative. Now, if you look over here, we have 15x minus 15x. If you have 15 of something and you take 15 of them away, are there any left? No. So what would you write if there's nothing left? No, but there's no x's left. If you say x, doesn't that imply that there's at least one? Yeah, like if you say, if you have x, if you write x equals, that means there's an x there. But if you have 15 of them and you take 15 away, are there any x's left? There's no x's left. What do you write when there's nothing? What number represents nothing? Hannah? 0, right? 0. Like 5 minus 5 is 0. So 15x minus 15x is 0. Good, Aja. So, or Asia, sorry. 0 equals, I keep doing that. It drives me bananas. I get so mad at myself when I mispronounce it. 0 equals, and then can we do anything with a negative 6? No. So just drop it down. And is this a true or false statement? Does 0 equal negative 6? No, this is a false statement. So if it's a false statement, is it infinitely many or no solutions? No solutions. And I want you to write that. No solution. So just writing the 0 does not equal negative 6 isn't enough. I want to see the no solution part. Good. Does that make reasonable sense, guys? Good. Yeah. Oh, yeah. It's pretty much the same. We're going to solve equations. You're going to be good at solving equations. All right. Are we done copying this one? Okay. On to number 2. What is our first step before we can use our 2-column method? Distribute. Hannah, what's negative 2 times 4x? Negative 8x. Good. Negative 2 times negative 1, a negative times a negative is a positive, and 2 times 1 is just 2. Good. Oh, and this is a typo, guys. See how this is a y? Change that into an x. That was my mistake. Forgot to fix that. Make that into an x. All right, so drop down your negative 8x equals negative, or minus 2, I'm sorry. So you have negative 8x minus 2 on the right. Now let's rearrange. And if you notice, guys, too, don't the left and the right-hand sides look really similar so far? Yeah, they do look really similar. So we're going to see what ends up happening here. We're going to put our 2 columns. So now let's go from left to right. Does our first negative 8x stay or go? It stays. Very good. What about our positive 2? Goes and becomes negative. Excellent. Now we're on the other side. What about our other negative 8x? It's going to go and become positive. Very good. And then what about this negative 2? It's going to stay. Drop it down. Good. Okay, well, I have negative 8x, and I'm adding another 8x to it. What's going to happen in a situation like that? 0, right? Anytime you have things that match, but they're opposite signs like that, it's going to cancel out. That's like saying you owed $8, you added $8 to it, I now don't owe anything, right? So that's just 0. So 0 equals, and then what's negative 2 minus 2? Hannah? Negative 4. Ladies and gentlemen, does 0 equal negative 4? It does not. So what do we say when it's not true? Very good. No solution. Excellent. People at home, any questions yet? All right. Good. Okay. Onward. We're going to do 3 together, then I'm going to have you guys try 4 on your own. Yeah. All right. Number 3. Kaysen, what would my first step in number 3 be? Yep, very good. We're going to multiply our 4. We need to distribute there. Good. So 4 times 1 is 4. And 4 times negative p is negative 4p. Equals, and did we do anything on the right yet? No, drop it down. Negative 4p plus 4. Good. Now let's work on our 2 columns here. Asia, this first 4, should that stay or go? Yep, it is going to go. Good, go, make it negative. The first negative 4p, Dallas, what do you think with that first negative 4p? It stays, very good. Now we're on to our other side. We got another negative 4p. Brooklyn, what's going to happen with that one? Excellent, it is going to go and become positive. And then our last 4, Jake, what do you think? Stays. Good. So now think about what we've done so far. If you have negative 4p plus 4p, what's going to happen? 0, cancels, right? Then on the other side, what's negative 4 plus 4? 0. Huh, everybody canceled. Does 0 equal 0? So this is a true statement, right? So what do we say when it's a true statement? Infinitely many solutions, good. And if you write just infinitely many instead of infinitely many solutions, that's okay. Someone asked me last year, can I just write IMS? No, I don't know what that means. If I'm looking at that quick, I'm gonna be like, what? Just write infinitely many or infinitely many solutions. I mean, you'll see me abbreviate sometimes, but you'll always know what it means. Good. All right, I want you guys to try out number 4. This is good practice for the homework because it's not a whole number. And I think there's like 2 on the homework that don't end up being whole numbers. So if you look at number 4, this one, there was no distributing you needed to do, right? Just go ahead and start rearranging it. So, Bailey, does that first 10K need to stay or go? It does need to stay, very good. Jesse, next 10K, or the 7, stay or go? The set, or oh, wait, which one did I say? I might have said the wrong one. The 7, this first 7 goes, yeah, okay. I just got mixed up in my brain. Yep, move that over, make it negative. Now we're on to the other side. Corey, -3, stay or go? Very good. Yep, it is going to stay. Good. And then our last -10K. Lynn, stay or go? And go and make it a positive. Okay. Now you might have looked at that and been like, wait, nothing cancels out though. That's okay. Because sometimes will there be an answer? Yeah. Are they likely to be all kind of mixed up together? Yeah. So what's 10k plus 10k going to give me? 20k equals negative 7 minus 3. Hannah? Negative 10. And then you look at that and you panic. And you panic because you go, what, negative 10 isn't divisible by 20. All right, and you go, oh God. That's okay. Fractions, decimals happen occasionally. On occasion they do. I highly encourage you to just leave them as a fraction personally. So what you would do here is we need to divide both sides by 20, right? And then you're going to have k equals negative 10 over 20. But can that be reduced? Absolutely. How can we reduce this fraction? What can we reduce the top and the bottom by here? Hannah? 10, yeah. Divide the top and the bottom by 10. And you're going to end up with negative 1 over 2. Could you also put it as a fraction? Sure. Does everything end up to be like a nice pretty fraction or a nice pretty decimal though? So you could write this as a fraction or a decimal, which would be negative 0.5. I personally prefer fractions because you guys don't have to like round, right? It's good practice with reducing your fractions. And sometimes if it's not a nice fraction, you know, and you turned it, good job, Mason, and you turned it into a decimal, it turns into like a crazy repeating decimal, and then you have to round it and well. Okay, good. Number 5. Oh, I got a lot of parentheses happening. What's going to have to happen first here? Distribute both sides, right? We got to distribute on both sides with this one. Good. So, Mason, help me distribute number 5. Tell me what to write on the left-hand side. Excellent. Yep. 3 times 2m to get 6m, and 3 times negative 2 to get negative 6. Excellent. Equals, and then on the other side, we need to distribute again. Nick, help me distribute on the right-hand side. Good. Excellent. Yep. 2 times 3m to get 6m. 2 times negative 3 to get negative 6. Do you guys notice anything about the left and the right-hand sides in this problem? Yep, they are exactly the same. Okay, so let's see what ends up happening when they're exactly the same. You might actually at some point, if you recognize this right away, be able to go directly to your final answer. But let's see what happens when we rearrange it. Anyone have a prediction? What's going to happen when we rearrange it? What do you think? Infinitely many. Let's see if that's what happens. So let's go through, let's rearrange. 6m, stay or go? Stay. Negative 6. Go, make it a positive. The other 6m. Go, make it a negative. And this other negative 6. Drop it down. All right. 6m minus 6m is going to give me 0. 6 minus 6 is going to give me 0. Was Brooklyn right? Infinitely many? Absolutely. Good. Good, good, good. And if you guys notice that right away, that's okay to write. You know, if you know, oh wait, the left and right hand sides are exactly the same. That's a true statement, right? You can go ahead and write it if you recognize it. You just want to be careful. Make sure you're correct. Good. Good, good. Number 6. Oops. Annalise, what do I do first in number 6? Oh, I'm not there yet. I got to distribute. So help me distribute the 3 on the left-hand side, Annalise. What would I get? Good. Yep. Good. 3 times 4x is 12x. 3 times 6 is 18. Excellent. Hannah, what about on the other side? Good. Good. What could you say right away if you notice that the left and right hand sides are exactly the same? Yeah, everybody's can cancel out. This is going to be infinitely many. If you recognize it, good. If you don't, keep going through your problem. Jake, 12x, stay or go? First one stays. Good. Brooklyn, the first 18. Go, make it a negative. The other 12x, gonna go, make it a negative. The other 18, keep it there, move it down. And everybody cancels, which makes it, what do we say? Infinitely many. Good. I think we got 2 more, a word problem, and then we're done, right? Excellent. Time to do our homework again today. People at home, any questions yet? All right. Hey, thanks for answering. I do like when people answer when I ask, or else I feel like I'm talking to myself, and that's awkward. All right, 2 more. Number 7, we got 6x plus 8 equals 14 plus 3x. Are things going to cancel out with this one? Do you see matching things on the left and right? No, this one's probably going to get us an answer, right? So let's see what ends up happening here. We have nothing to distribute, so go ahead and put your 2 columns. Owen, first 6x, is it going to stay or go? Yes, it is going to stay. Good. Now we got the 8. Who we back up to? Aiden, what do you think is going to happen with that 8? Is it going to stay or go? Any idea, Aiden? All right. I don't know if Aiden's there. Asia, help him out. What do we need to do with that 8? Okay. Yeah, you need to move it and we need to turn it into a what, Asia? A negative. Good. Glad you can talk now. That happens sometimes. Bailey, what about the 14? It does stay. Good. And then last part, Kaysen, 3x, stay or go? It goes and becomes a negative. Excellent. Combine our like terms, 6x minus 3x. Dallas, what's 6x minus 3x going to give us? 3x. Very good. Negative 8 plus 14. Jesse, what's negative 8 plus 14 going to give us? 6. Good. And then final step, Corey, what do we do last? Very good. We're going to divide both sides by 3. And we're going to get the x equals 2. You guys are going to be equation solving genies by the time we're done here. And this one, it did say to indicate, so does this have one solution, no solution, or infinitely many? Yeah, we actually get an answer, so this is one solution. How you doing back there, Hannah? I saw you give me a confused look. Oh, okay. You do, you divide it by 3. Oh, you just wrote something funny down? Okay, that happens. I do that all the time. Always double check my adding and subtracting. I'll do something silly. Good, last one, guys. You do have to do the distributive property first. Take a look at it though, guys, before we even do it. Make a prediction. What do you think is going to happen? Are things going to cancel out, or is this one going to give us an answer? How can you tell? Very good. Yep. We got that 12. That 6 times 2 is going to give us a 12. We're going to end up with 12 x's on both sides. Something's going to cancel. It's always good to kind of just like notice those things before to kind of see where the problem's going to take us. So Annalise said we need to distribute first. So let's go ahead and do that. We're going to drop down our left-hand side here, 12x plus 6. Oh, my pen turned off. 12x plus 6 equals, and then let's distribute. 6 times 2x is 12x. 6 times 6 is 36. Get our 2 columns. Lynn, first 12x, stay or go? That's okay. The first 12x, should it stay or should it go? It is going, yeah, it is going to stay. Good. Mason, the first 6, stay or go? Go and make it a negative. Excellent. 12x. Nick, what about that second 12x? Excellent. It would go and become a negative. And then Owen, the 36, stay or go? Owen says it stays. All right, and then we're going to simplify. Jake, what's going to happen with 12x minus 12x? It is 0. And Hannah, what's going to happen with negative 6 plus 36? It is going to become 30. And Brooklyn, is this a true or a false statement? It is false, so what do we say? No solution. Very good. Cool. I think we're killing it, guys. We're doing good. Very cool. Do we feel good about it? Good. Good. I feel like we're doing really well. And people are responding in the Google Meet, and it's just a good Friday. Lovely. I don't think I missed anyone for attendance. Everybody. Okay. Last thing, guys, and then you're going to get time to do your homework. And I think there might even be a problem or two. I want to take a look on the homework together. Okay. So word problems with variables on both sides, because we've been dealing with equations with variables on both sides. We don't see these too often, but I have seen them show up on my fair share of standardized tests. So I'd like you guys to have seen them. Okay. So this says Jim A charges a $70 joiner's fee and a $15 per month to be a member. Jim B charges a $35 joiner's fee and a $30 per month fee to be a member. How many months would the cost of both memberships be the same? So this is like saying you signed up at Jim A, your buddy signed up at Jim B. At what point have you guys paid the same for your membership, even if some of the fees are a little different? Okay. So let's go through, let's annotate it, let's circle our numbers, box our math action words, see what we're being asked. So let's start by circling our numbers. Annalise, where do we have some important numbers in this problem? Yeah, With gym A, our important numbers are 70 and 15, right? With gym B, our important numbers are 35 and 30. Good. Where do we see some important math action words with gym A? Per month. Very good. Yeah, per month. What does per mean again? Anyone remember? Multiply. Very good. Yeah, that means we're going to multiply. Anything else that could maybe help us with our equation? Oh yeah, a fee. A fee is something you got to pay, right? That's going to be tacked onto your bill. So fees we need to add in. All right, you're going to have to pay them money for that. So if we're talking about a total bill. And then do the same math action words happen with gym B? Yeah, because it's made up of kind of the same components here. We got a fee that we're going to have to pay, and then we have a per month charge. And per means multiply. So first, let's define our variable. It asks me after how many months would the cost be the same? So what are we solving for? Number of months. Yeah, the number of months, because we know, so technically the equation does have to do with the cost. And so you're right, we're trying to figure out when does the cost of A equal the cost of B, but that depends on the number of months. So months is going to be our variable here. So I'm going to use M equals number of months. Good. Okay. Now it is saying after how many months would the cost of the gym memberships be the same? Now think algebra, guys. Same is actually a math action word here. If I tell you, you guys have the same amount of money, what's a math symbol that could represent same? Hannah? Equal. Same means equal. So your problem is kind of asking you here, when is gym A going to equal gym B? Does that kind of make sense? Okay. Now, gym A has some certain costs going on with it, right? Gym B has some other costs going on with it. So let's focus on one at a time, which is part of the reason I tried to kind of color coordinate this for you guys. So let's look at gym A. You're joining gym A. What are you going to have to pay at gym A? You got to pay $70 up front, right? Hand them the money. Swipe your debit card, whatever it is. Do you think so? If that's a fee, that tends to get added on to your bill, right? So we got to do 70 plus. And then what else does gym A make you pay? Hannah? $15 per month. So 15 per means multiply and then months, right? Do we know how many months yet? No, but what letter are we using to represent it? M. So we're going to do plus 15. Oops, that's an ugly 15 now. Plus 15 M. Does that kind of make sense for gym A? You got your $70 up front plus another $15 per month. Are we good with the left-hand side? Is the right-hand side going to look pretty similar? Just with some different numbers, right? Gym B has the same stuff going on, just with different amounts. So what's our fee for gym B? We got to pay $35 up front, right as we walk in the door. Plus, what's our monthly payment at gym B? $30. So this is kind of a situation where if you're going to gym A, you're paying more up front, right? But a little less each month. And at gym B, you're paying a little less up front, but a little more each month, right? So it's the point of this problem is at some point to show you, like at some point they're going to kind of even out, right? We're trying to find out when does it even out. So we have an equation. Can we use our 2-column method now to solve it? Yeah, we can. Let's do that. So this is part of our answer. I might ask you to like write an equation. This is the equation that represents this situation. Now we're going to solve it though. So let's get our 2 columns going on and let's solve. So 2 columns, 70, stay or go? Go, make it a negative. That's ugly. Guys, I wonder if I'll ever be able to write neatly with this stylus. You guys all probably just think I have really bad handwriting. I actually have really good handwriting. I just can't. So 15M, stay or go? It is going to stay. All right, now we're on the other side. 35, stay or go? Stay. 30M, stay or go? Go, make it a negative. And then let's simplify. 15M minus 30M is? What kind? Negative. Negative 15M equals negative 70 plus 35 is? Don't guess, use your calculator if you need to. See you all sitting there trying to work it out in your heads. That would be if you were adding them. One of them's negative, so technically you subtract. Negative 35, good. Yeah, since one's negative, one's positive, think like 70 minus 35. And then since the 70 is negative, right, that's the bigger number, your ending value will be negative. Hannah, what's up? I don't think so. You might have plugged something in wrong. No, it's 35. I just double checked. All right, now let's divide. Now, is this going to divide nicely? No, it's not. Is that okay though? Yeah, sometimes that happens, especially when like we're dealing with like real world problems and money. That's okay. It's going to happen. Now this one, do you really ever talk about months in like fractions? Would I say like 5/3 of a month? No, decimals would probably make a little bit more sense here, right? Because then we can look and we can round. So we're going to divide both sides by 15M. Negative 15M, I mean. So M equals, so let's plug that into our calculators. You cannot do that in your head. 7 what? 7/3. Yeah, we could reduce it if we wanted to, right? That's going to become a positive and they're both divisible by 5. So that'd be 7/3. But if I go 7/3 of a month, you're like, I don't know what that means, right? So let's turn it into a decimal. You would do 7 divided by 3, which actually ends up being 2.3 repeating.